This is a movie on how to do gram-to-gram stoichiometry. And the key thing to remember about gram-to-gram stoichiometry is really stoichiometry only occurs in one step always. It's when we get the mole ratio from our chemical reaction. But we have to convert grams of the moles first, and then do our chemical reaction moles, and then get out of moles back into grams. And we always have this format. There's a gram here, a 1 mole here, mole without numbers, and 1 mole on the bottom, and a gram over here. So this is what our bridge system always looks like when we're doing gram-to-gram stoichiometry. So let's get started. 25 grams of potassium chlorate will produce how many grams of oxygen? Well, this is our potassium chlorate here. So what I'm going to do is I'm going to put 25.0, and this is grams of potassium chlorate. I'll sneak it in here, KClO3. And we're trying to figure out how many grams of oxygen that we're going to produce. So I'm going to put grams O2 over here. So this is what's given, and this is what we're trying to find. So immediately, let's start filling in the rest of the stuff here. So I know that this is going to be 1 mole of KClO3, and on the bottom over here, I'll have mole KClO3. Here, I'll have mole of oxygen, O2. I know I'll have mole oxygen over here. So you see the pattern. What I know goes here, over here, and on the bottom over here. What I'm trying to find, we put moles of oxygen there and right there. This guarantees that we're going to be converting grams of KCl3 into moles initially. Then we're going to make our mole comparison from the chemical equation, and then we're going to get out of moles back into grams. So how does this work? Well, once I label this here, I know all I need is the formula mass underneath this. So it's 1 potassium, 1 chlorine, and 3 oxygens. That equals 122.6 grams of KClO3. Over here, I need my grams of oxygen. This is our moles, so I'm going to need a molar mass there. I'll round this one, that's twice oxygen. I'll round it to 16 times 2. So that's what, 32.0 grams of oxygen. Now remember, this comes from the periodic table. Okay, make sure my point shows up there. And this comes from the periodic table. Now where do I get these numbers from? This is truly where stoichiometry is. I'm going to go up here for oxygen. I see that there's a 3 there, so I'm going to put a 3 there for the moles. And my KClO3, there's a 2 there, and I'm going to put a 2 there for that. So this is the part where stoichiometry really happens, when we use the moles with the balanced chemical equation. This is a mole conversion, the molar mass of this one, and this is a mole conversion, the molar mass of this one. So now mathematically, what are we going to do here to figure out our answer? Well, I've got my calculator. I'm going to take 25.0. Anything on the bottom is going to be divided. I'm going to divide by 122.6 because that's on the bottom. Then I'll times it by 3 because that's on the top. I'll divide by 2 because that's on the bottom, times 32.0. And my answer is 9.79 grams of oxygen. 9.79 grams of oxygen. Okay, and that's how you do gram-to-gram stoichiometry. Technically, it's a 3-stepper. But really, stoichiometry exists right here when we use the moles as compared to our balanced equation. That's a mole conversion there, and this is a mole conversion here. Let's try one more example to see this pattern. 32.4 grams of oxygen are produced. How many grams of potassium chloride are produced? Okay, let's fill in our gaps here. So once again, you see the same pattern. I'm going to put what I know here, 32.4 grams of oxygen, that's O2. How many grams of potassium chloride are produced? This is KCl here, potassium chloride, so grams of KCl. So as soon as I do that, I'm going to put O2 here and O2 right here. I'm going to put KCl here and KCl here. Okay, I need a molar mass of this one, twice times oxygen, 2 times 16 is 32.0 grams of oxygen. KCl is 1 potassium and 1 chlorine. That's 74.5 when you add those two together. Grams of KCl. Okay, now I'm going to get the numbers that go in front of here. I'm just going to go to the balanced equation. I see a 2 here in front of this KCl. I see a 3 here in front of that oxygen, so I'm going to put that right there. So all of these gram-to-gram stoichiometries occur the same way. You have a mole conversion, then you look at the balanced equation, and then another mole conversion. So their pattern is identical. So I'm going to take 32.4. I'll divide that by 32.0, times that by 2, divided by 3, and times by 74.5. I'm getting 50.3 grams of KCl. Okay, so that's how gram-to-gram stoichiometry happens. Notice how I'm labeling everything everywhere along the way so I can clearly track. See oxygen, 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 a fourth oxygen, and KCl, 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 KCl. 4 times I write that. And you need to do that to make sure you are doing this correctly. Also, notice how I don't multiply anything or divide by ones because I know that's not going to change anything. I just took 32.4 divided by 32.0 times 2 divided by 3 times 74.5. And there you have mole-to-mole stoichiometry.